Did you know that the fresh cut fruit market is growing? In fact, recently, consumers are shifting towards healthier and convenient diets. So, the fresh cut fruit market is growing rapidly. However, the cut process promotes water loss, respiration, ethylene production, contamination, etc. So, fresh cut fruit is easy to spoilage. On the other hand, most of those physicochemical or physiological reactions are suppressed by cold temperature. Therefore, refrigeration technology is effective to store fruits and vegetables. However, when we lower the storage temperature to the sub-zero temperature, food will be frozen. When food was frozen, ice crystals will damage its tissue, and it causes physicochemical change and drip loss. So, these quality changes are unfavored for fresh fruits and vegetables. Then we want you to think about supercooled storage. Supercooled storage is a method to store food under the freezing temperature without freezing. Therefore, it is considered that supercooled storage is effective to extend the shelf life of fresh fruits and vegetables. However, there is no evidence about this. Therefore, in this study, our object is to evaluate the influence of supercooled storage on the quality of fresh cut fruits. And here, we use the Fuji apple as a model sample of fresh cut fruits. In this study, whole apple was cut into 16 equal edges, then dipped in saline, wiped surface water, and packaged by OPP film. After that, samples were stored at 5 and -5 degrees Celsius for 10 days. In the result, water loss and total color change of supercooled sample was suppressed compared to samples stored at 5 degrees Celsius. So, it is considered that supercooled storage is effective to suppress water evaporation and the browning of fresh cut apples. We also evaluate pH, soluble solid content, and firmness of fresh cut apples, but these three properties had no remarkable changes during storage. Lastly, total aerobic bacteria count of samples were measured by standard agar plate culture method. In the result, the number of total aerobic bacteria was increased as samples stored at 5 degrees Celsius. Instead, it was decreased at supercooled samples throughout 10 days. It means supercooled storage would suppress total aerobic bacteria count of fresh cut apples. Overall, from this study, we suggest that supercooled storage would suppress water loss and browning of fresh cut apples. And also, supercooled storage would remarkably suppress total aerobic bacteria count of fresh cut apples. So, supercooled storage could longer the shelf life of fresh cut apples. Thank you for listening.